Hello ladies and gentlemen, this is Dean from WafflePie, and this is Linear Algebra. Here I'll show you some properties of vectors that you can find using dot products, as we defined in the last video. First, let's look at a vector in the xy plane. Pythagorean theorem tells us that the hypotenuse of this triangle here is given by a squared plus b squared equals c squared, which is actually a consequence of the hypotenuse being a length of this vector. In later years of high school and onward, you'll probably see this as c equals the square root of a squared plus b squared, as it simplifies c. Well, if you see it like this, a and b are the legs of the triangle and are given by the components of the vector. You might be able to tell then that c squared is the dot product of a vector with itself, because remember, the dot product is just a number. What's interesting here is that this holds for any dimension, any number of dimensions that you want. So in general, the length of a vector, called the norm, is given by the square root of v dot v, denoted as norm v, which is two absolute signs. Another thing you can do with dot products using norms is you can find the angle between two vectors. But how can we do this? Well, it has to do with the cosine rule that you might have learned in trigonometry, but the proof isn't important. Just know that the formula is cos theta is equal to u dot v over norm of u times the norm of v, which is equal to theta is equal to arc cos of u dot v over norm u norm v. A somewhat shortened case is to state that when u dot v equals 0, the vectors are orthogonal, as arc cos of 0 is equal to pi over 2 or 90 degrees. This shows rather trivially that the 0 vector is perpendicular to every vector, even itself. Finally, dot products allow us to find projections, which are essentially the youth component of v. You can think of this as shining a light directly above v, such that it lays a shadow of v onto u. The formula here is just a foreshortening of u, and it is u dot v divided by u dot u times u. This case doesn't show up a lot in classes like Linear Algebra 1 or 2, but I'd imagine that it has some practical use somewhere in engineering or something.